Hi, we are from Group 5. We are Group 5 from class DAM 12903, Technical Drawing and CAD Section 2. We are presenting our AutoCAD project, that is nail clipper. This is our group member, consists of 4 people.
Assalamualaikum and hi. My name is Hussein bin Nazaruddin. My metric number is AA250738 and I'm from section 2. I am one of the group 5 members and right now I'm going to present to you guys about my project. Now let's move on to the slide. I'm going to present to you guys about introduction. Okay. Introduction. A nail caliper is a simple hand tool used for trimming and maintaining fingernails and toenails. It is one of the most commonly used personal grooming products due to its compact design, easy to use, and effectiveness in keeping nails clean and properly shaped. Most nail calipers are manufactured from stainless steel to make them durable, corrosion resistant, and suitable for long-term daily use. The nail caliper operates through a basic lever mechanism that applies force to two sharp cutting edge, allowing nails to be cut smoothly and safely. Despite its simple appearance, the product is made up of several components, such as the upper and lower body, lever, pivot pin, and nail file, each of which contributes to its overall function. Because of its practical design and widespread use, the nail caliper is an excellent example of a consumer product that combines functionality, durability, and ease of manufacturing. Understanding its structure and components provides valuable insight into product design, material selection, assembly methods, and the importance of producing reliable everyday tools that meet the all of users' needs.
Hi, my name is Muhammad Sadar Hakim Birizal, Novometric AA250056. Now, I would like to explain the objectives of our project. The main focus of this project is to apply reverse engineering techniques using AutoCAD software. We begin by measuring and manually sketching the nail clipper components before reconstructing them as engineering drawings and 3D models. Through this project, we aim to improve our skills in sketching, engineering drawing, and CAD modeling, CAD modeling. We also learn how to interpret standard engineering drawings, understand the reverse engineering process, and strengthen our teamwork by completing the project collaboratively.
Hai, Assalamualaikum. My name is Muhammad Nasir Fikri bin Muhammad Nazaruddin. My number metric is AA250050. First of all, I can explain the literal review. The first is 2.1 product overview and application. The selected product is nail caliper, a tool used to cut, trim fingernail and toenail. It's a wheel used to maintain personal hygiene and consists of main component, such as the body lever, cutting blades, and connecting pin. Its compact size to ease of use make it a practice everyday tool. Next, 2.2 working physical and machine. The first, a nail caliper work by pressing the lever which transfer force to the sharp blade to cut the nail effectively. The connecting pin allow smooth movement between the component, making the cutting process simple, effective. Next, 2.3, engineering material manufacturing process. Is a near caliper or componently made to stainless and steel because it's strong. Crosses resistant, durable and easy to clean. The manufacturing process include strapping, forming head and treatment, assembly and polishing to produce a sharp, long-lasting product. Last, 2.4, computer aided design and standard. The nail caliper was modeled using CAD software based on measurement taken with a millimeter rule. Each component was cracked separately and assembled using bottom-up method. Standard engineer drawing, including orthographic and isometric view. With a clear dimension, we are used the ensure proper documentation.
Next is the history of the nail clipper. The nail clipper is a hand tool used to trim fingernails and toenails. Before nail clippers were invented, people usually trimmed their nails using knives or scissors, which were less safe and less convenient. In 1975, Valentin Fogarty patented one of the earliest nail trimming devices. Over the years, the design was improved into the modern lever type nail clipper that we use today. Because of its simple mechanism, durability and ease of use, the nail clipper has become an essential personal grooming tool worldwide. Now, I will explain how the nail clipper works. A standard nail clipper consists of a lever, an upper blade, a lower body, a pivot pin, and a metal file. When the lever is pressed, the applied force is transferred through the pivot pin, causing the two cutting blades to close together and cut the nail. This simple lever mechanism increases the applied force, allowing the nail to be cut efficiently while requiring only a small amount of effort from the user.
In this slide, I will talk about the component physical shape and its function. First, we have the upper lever, a curved metal lever mounted on top of the caliper. The function is to apply the force to the cutting blades when it pressed. Second, we have upper blade, the movable curved cutting blade attached to the lever. Works with the lower blade to cut the nail. Third, we have lower blade, the stationary base of the nail clipper. Supports the nail and provides the lower cutting edge. Next, we have the pivot pin. Pivot pin is a small cylindrical pin connecting to the lever and blades. Its function is acts as the pivot point and allowing smooth rotational movement. Lastly, we have the nail file, a thin metal extension integrated with the lever. It is used to smooth rough nail edge and clean under the nail.
Hi, my name is Yusuf Isharizal and my number matrix is AA250130, and I will talk about the 4 key subcomponents. To understand how this product tool functions, we first isolated and analyzed its 4 primary structural components. First, we have the base. This is the rigid flat bottom plate that acts as the primary datum pin for the assembly. It is completely stationary during the operation and provides the solid foundation against which shearing force are directed. Second is the blade. This is the upper curved leaf component. It is stamped from spring tempered stainless steel, allowing it to behave as the cantilever leaf spring. It contains a curved shearing edge at the front that aligns with the base. The third one is the lever. This is the primary control interface. It's ergonomically shaped handle features a hook-style socket at the front to capture the pivot pin, translating the user's downward thumb pressure into a concentrated vertical movement. And finally, we have the pin act as the central vertical anchor. It is left-turn cylindrical pin featuring a wide bottom head to catch the lower base, and a small groove near the top that securely locks into the lever's hook socket, holding the entire assembly under the slight constant tension.
Now I'm going to present about bill of materials. In this production, all of the materials component were using stainless steel materials. It is because it can avoid the product materials from being rusty, so the product can last longer. Okay, about the upper level component, the material, like I said, stainless steel. Quantity, uh, the quantity we were using is one. Okay, so the function is to apply force to operate the nail clipper. For upper blade, the material is stainless steel. The quantity is same one, and the function is to forms the upper cutting edge for trimming nails. For lower blade, the material is stainless steel. The quantity is also one, and the function is to support the nail and provide the lower cutting edge. Okay, next for the next component is pivot pin. The materials also stainless steel. The quantity is also one, and the function is to connect the lever and the blades to allow rotational movement. And lastly, nail file. The material is also stainless steel, and the quantity also. It used to smooth the nail edge and cleanse under the nail after trimming.
Next, let's discuss the product's operational process. The clipper operates on the compound system, a class 2 mechanical lever working in tandem with a cantilever spring mechanism. This process is divided into three distinct phases. Phase 1 is setup and activation. When stored, the lever lies flat against the body to minimize space. To operate, the user rotates the lever 180 degree around the vertical axis of the pin, then flips it up like this. And this rests a raised ridge on the underside of the lever is fulcrum firmly against the upper base blade, creating the open jaw configuration. Phase 2 is a force application and shearing. When user presses down on the lever like this, the mechanical action begins. Using the center pin's head as the tension anchor, the lever pivots down on its fulcrum ridge. This amplifies the finger force, displacing the flexible upper blade downward. The curved cutting edge of the upper blade meets the flat edge on the stationary base, creating a highly concentrated shearing force capable of cutting through a dense material cleanly. The final step in the cycle is the phase 3, the mechanical return. Once the user releases the downward pressure on the control lever, the stored elastic potential energy within the deformed upper blade is discharged. Because the blade was manufactured to act as a spring, it immediately returns to its natural curved open jaw. These upward vertical forces pushes against the front of the control lever, automatically pivoting it back up to its ready position. This mechanical return loop operates seamlessly without requiring any secondary spring, demonstrating the clever self-resetting efficiency of this simple mechanism.
Next, type of product available in market. All of the product that I list here is commonly used in every country. So let's talk about it. Firstly, we have standard nail clipper. This is the most common type used for daily fingernail trimming. Second, we have large toenail clipper. This clipper is designed for trimming thicker and harder toenails. Next, we have nipper type nail clipper. The features here is like plier-like handles for better control and precision. Fourth, we have the scissors type nail clipper. It operates like a pair of small scissors and provides precise trimming. It commonly used for pet. Okay, next we have the baby nail clipper, specifically designed for infants and child. Lastly, we have the electric nail trimmer, a battery-powered device that trims or file nails automatically.
In conclusion, this project successfully achieved its objectives by applying the reverse engineering process to a nail clipper using AutoCAD. Through disassembly, measurement, manual sketching, and CAD modeling, we successfully produced accurate engineering drawings and 3D models. This project enhanced our understanding of engineering drawing and reverse engineering while improving our technical problem solving and teamwork skills. That's all from us. Thank you for your attention, and that concludes our presentation. Thank you.